Yeah, okay, so welcome everybody to our next WestGrid Town Hall. There are three of us at the moment. I'm Patrick Mann, the WestGrid Director of Operations. Lance will be around. He's the Senior Systems Administrator for Cedar. And Alex is here, our WestGrid Training and Viz Specialist. And so the three of us will be speaking. A couple of admin things. You can ask questions on email or in the group chat with a video here, and of course, if you can mute your mic, maybe even turn off your camera if you're not asking a question, that would be great.
And if you want to see the presentation slides a bit bigger, you can double-click on them and undock the slides, and you can enlarge them as needed. I've also added a link on the Eventbrite page to a PDF of today's slides, so you can open them yourself and look through them at your own speed.
Yeah, and as you all know, Lance is working, I think, on the Cedar outage today for the upgrade. I've got a slide about that, but it wouldn't be too surprising if he's deep in the innards of Cedar somewhere. But we can work with that. Okay, so today we're going to look at the whole business of system instability. It's a pretty good time to do that because, indeed, Cedar is undergoing quite a long outage for the next few days, and it's things like that we thought we'd concentrate on a bit here about what are the causes of this kind of instability, how much can you expect out of it, and then Alex was going to talk a little bit about the best practices that one can start in running your jobs and such to deal with these kinds of instabilities. Then I've got the usual section about WestGrid and Compute Canada. We'll probably try to get through that pretty quickly, and then a quick overview of the user training. Let's see, so I guess Lance maybe is not able to make it. Did you,
want to do
Aaron?
your part first, Patrick?
I could do that, yeah. We could give Alex or Lance a couple of more minutes. Okay, I think that's probably quite reasonable. So I will briefly talk about the system, or just my usual update. Where the heck is it?
Slide 8.
Yeah. Yeah, okay, that's probably a good idea. Okay, I keep me on time here because I think we should do this as quickly as possible, and then leave lots of time for the best practices on outages and such. Okay, so usual outages and maintenance then. Graham had an outage back in February. Cedar today is the major outage, and Cedar has had continual file system issues, one unexpected power outage at SFU on the 27th of January. So a couple of things. The big one, though, has been the slash project issues, and they're pretty much continuing. That's the Luster file system with the metadata servers, and that's one of the things we'll hear much more about today. Niagara had a big outage. They were installing some power generators and a larger UPS, and I've got a couple of extra slides here then about these major outages. So today, Cedar's gone down, and they're moving the Luster metadata servers from the old SAS drives to new SSDs. So that's we hope is going to be a really big improvement. The SSDs are way faster, and it's proven to be pretty easy for users to start doing lots and lots of file I/O and to essentially break the slash project Luster, or at least make it slow down immensely. And along the way, they're updating Luster, updating CentOS, and the OPA drivers. So just to remind everybody, I hope everybody's seen the announcements, but today the machine went down. Today is when all the, but that Luster metadata server change means that all the old metadata has to be copied from the old SAS drives to the new SSDs, and that turns out to be a major operation with requirements for very specialized copying. So they've given themselves a few days from, they'll start it today and have pessimistically thinking that they'll finish it on Wednesday, maybe a bit earlier. But the plan then is that tomorrow, assuming the upgrades have gone well, they can still bring Cedar up, but it won't have /project. So you won't be able to run anything that uses data in /project. /project won't be mounted. And if a job, and jobs in the queue from previous to today will maybe start, and if they're using /project, then they'll fail and you'll have to resubmit. Yeah, so there's the quick overview of what Cedar's doing. And I wanted to also mention the Arbutus upgrade. This slide we've had up now, I think, for the last 3 town halls. So it's almost done. Almost all the projects have been moved to the new Arbutus cloud. And if you remember, the old hardware is being deactivated and then integrated back into the new cloud. So that was a big operation, and it's pretty much done. Just have that hardware being moved over. So that's really nice to see that. Those projects that have not been done yet are rather big, special external projects and have just required the cloud group to work directly with those projects. So great stuff, and I hope everybody's now on Arbutus and have managed to get all their platforms and portals up and running again. Lots of reminders and bits and pieces here. This one's about Orcinus. Remember, Orcinus is at UBC. The defunding date is March 31st. And I'm really want to thank UBC because they're going to keep Orcinus going for as long as possible. And the key here is that we have a WestGrid network and authorization system that's scheduled for decommissioning sometime later in the summer. We put down June here, but it'll probably be a bit later than that. And until that, UBC will keep Orcinus going. Note that Orcinus is not being allocated this year. Since it's defunded, it's not formally in the Compute Canada sites. So UBC is going to run this very opportunistically. You just get standard priority on it, but some preference will be given to UBC-based users. And I've got Roman Baranovsky, the senior systems or the senior guy at UBC, his address there, and you can call him if you got any issues. I want to remind you that Orcinus is best effort, and it has been for a while. So no guarantees on disk systems and storage reliability in particular. So yeah, you can certainly use Orcinus, but you should have some other, if any important data, you should be keeping that somewhere else. And of course, somewhere else for us probably means on one of the /project areas on the new sites. And then Beluga itself. I remember Beluga is the new machine in McGill. They've had some real issues trying to get it installed. Dell is the provider, is the vendor. There turned out the machine wouldn't satisfy some of its tests, and it turned out after I think over a month, a couple of months almost of work, they've traced it down to a bunch of faulty power supplies. So they're replacing all the power supplies. A big effort. But just a couple of weeks ago, it was finally handed over to Quebec for their own acceptance tests. Those are happening right now. But we've been significantly delayed. I think in previous town halls I've said that we're always hopeful and we thought that shouldn't be much of a problem. But there's really significant delays. The Quebec guys are still working towards getting the machine up and running in a production configuration in the next couple of weeks, mid-March, something like that, maybe a bit later. But of course, still a few hoops to go through. So I don't know if it'll be available for April and the new RAC 2019 allocations. It's at risk, so keep an eye on announcements for that, and we'll have some process if it's not available. But not looking too bad. I think it should be up. And that feeds us into the resource allocation competition. All our deliberations have been completed. We've had our big meetings with the science reviewers and all that kind of stuff, scored the proposals, did the allocations, and notifications are supposed to go out on March 15th. So all the PIs should receive your allocations around about March 15th. I don't have any formal statistics yet, or at least they're all unofficial. The project manager, Eduardo, is working on those. But these are sort of unofficial stats, just to give you some idea. Pretty much like last year, essentially even worse. We've been asked for a lot more than we actually have. We have made some proposals back to CFI and the federal government to cover this kind of shortfall, and I think we're hopeful. But yeah, storage. For the first time in my memory, I think we got asked for more storage than we actually have. Fortunately, Cedar is installing, or has installed, 10 petabytes more, so we can cover that when it comes to the actuals. But both CPU and GPU way up there. Over 2.5 times more CPU was asked for than we got, and over 5 times as much GPU. Cloud and both CPU and storage are sort of around about reasonable numbers that we can handle. But that gives you some idea. It was, again, a very competitive environment for rack. I think maybe at the next town hall, or we'll have a lot of the details, and we can go into all the stats and see how we did. And as usual, we have this renewal phase coming up, and that's when we ask you all just to confirm that you're still around and you still like your account. So every user's got to renew your accounts. I think expected opening is April 8th. So the forms will go out April 8th or be turned on April 8th, and you got a month to do those renewals. And remember, these are kind of annoying, but we really need them. We have to keep up to date, especially for our funders and CFI and such, on who our users are and what they're doing and all that kind of thing. So yeah, when this comes out, please go for it. And we'll continue to warn you, and you'll get lots of reminders. I got asked a few times about ownCloud, the shared Dropbox-like cloud system at UBC. Sorry, at SFU, run by SFU and WestGrid at the moment. ownCloud is currently run as the WestGrid service. The plan is that that's going to be moved to a cloud partition on Cedar, and with an update to the NextCloud software, but it'll look the same. So that's what's in the works, but there are no detailed plans yet. So somewhere in the summer, I think we'll have an ownCloud outage and move all the data across and start it up. So there'll be a change, but this is just because I keep getting asked if ownCloud's going to keep going, and yes, it is, but it'll keep going as a Compute Canada service. And another thing I get asked about regularly is nearline. Remember, that's the tape backup operation on Cedar. Indeed, everything is backed up to tape right now, but it's backed up through systems stuff, and that's for disaster recovery and those kinds of things. The nearline one is a user-managed approach where you can copy your files to a particular location, and then the files will be auto-migrated to tape. And when you go back and have a look at the files, the tape system will automatically bring it back, maybe with some delay. The issue at the moment is that we want to make sure when we have a tape copy that we have multiple tape copies, and in particular a distributed tape system between SFU, Waterloo, and Toronto. So Compute Canada is working on that, still aiming for an April introduction of nearline. But I've been saying that, I think, for 3 years or 2 years, that we'll have nearline, and we don't have it yet. It's turning out not to be trivial. So yeah, we're hoping, but we'll keep you up to date on that one. Graham has some FPGAs, just announced that yesterday, or Wednesday, I think. So yeah, if you got anything to that might use that, you can get rid of the Graham guys, or sorry, get in contact with the Graham guys. Okay, that's kind of it for me. I don't see Lance. Okay, no response. Aaron, have you heard from Lance at all?
No, I haven't heard anything.
Okay.
Adam says he may be about 10 minutes more.
Okay, I think we need to get going though. So
maybe the training, let Alex continue on with the training slides, and then we can.
Okay, we can try that. Alex, you want to do your user training?
Sure, I can talk about it. It will not take 10 minutes, but
yeah.
look at me. Yeah.
Yeah.
So good morning, everybody. Upcoming user training. Yes, we have online webinars, as you probably know, running every 2 weeks on Wednesdays at 10 o'clock Pacific, 11 o'clock Mountain. And we have a full schedule until the end of May, essentially. So the webinar topics of coming events are shown here on the slide. Next week, we're going to have a visualization webinar. So Dmitry Rosmanov, a data analyst and WestGrid analyst from the University of Calgary, is going to talk about visual molecular dynamics, how to visualize biomolecular and molecular dynamic simulations with VMD. And then we have a variety of topics for the rest of the term. So if you want to register for any of these, please follow the link on this slide, and this will take you to a description, and then you can click on individual webinar, and you can register there. And all webinars are taking place in the same room. It's a WestGrid training room in video, and if you want more details, please go to the website that you see on the slide. Next slide, please. We have also a number of in-person training events, quite a few big ones this year. So in 2 weeks, we have 4 days of workshops at SFU. So these are going to be workshops for beginners. We're going to do Introduction to Linux command line on day 1, and for that we'll be using a remote cluster. So all attendees will have a guest account, and we'll do some cluster-specific exercises. Then on day 2 is going to be in-depth introduction to high-performance computing with lots of exercises. Day 3 is going to be visualization, and day 4 is going to be introduction to main concepts of parallel programming and parallel programming with Chapel language. So if you're interested in that, if you are in Vancouver area, so anybody is welcome. If you're from UBC, you're welcome to attend as well. It's going to be 4 days in 2.5 weeks, and you can register for any individual day, or you can register for all 4 days, and it's free. And then we have, so 2 other big events that I want to mention is we have our summer schools. So the summer school at the University of Calgary is going to take place the last week of May, and we're going to have a formal announcement probably next week with a detailed program. So right now we're just putting the final touches on the program. So we're going to have 3 streams, and one of the streams in Calgary is going to be devoted to machine learning. And then sometime in June, probably end of June, we're going to have a summer school at UBC, and we'll probably decide on the exact date today, and we're going to announce it next week as well. Next slide, please. And finally, I want to mention that we have, just a reminder, we have the training materials page where we put all our slides, all our training materials from summer schools, from online events, and the recordings from online events as well. So the recent webinars that we had, memory debugging with Valgrind, data analysis with YT, and text parsing and matching in HPC. So all of these are archived with slides, and some of them have videos posted as well. So just go to the respective session in the menu at the top, and we keep it up to date. So we remove all materials, and we try to post everything new there. So it's really a great resource for everybody. That's all I wanted to say in this section.
Okay, I guess we don't have Lance, so I think, Aaron, we better just dive in to Alex's end of things. I can do a quick introduction, and yeah, it's unfortunate, but I guess Lance is working away on other things. So I'm going to just very, very quickly introduce Alex. The introduction was just what are some causes of these kinds of system instabilities that we've got. I just note that systems like Cedar and Graham, they're massive systems with lots and lots of components, tons of memory cards, tons of memory sticks, internal drives, all that kind of thing. And there is a continuous level of just straight component failures. Memory fails, disk drives fail, something like that. And we have a few other points that I just made here that that they're all leading edge stuff. We bought the latest hardware and the latest CPUs, latest GPUs. Software is very, very optimized for performance, not necessarily for reliability. And there aren't too many of these machines, so we don't have 10 million users just working on the machines and finding bugs. A key part, when we see as today with Cedar, is these huge shared file systems. We got tens of thousands of drives, and they fail every now and again. So there's got to be complex redundancy systems, all stuff like around that. And again, performance is paramount. We got to satisfy maybe hundreds of users who are doing things, running jobs, thousands of jobs running on these systems. And then we do have a very broad user mix. So some people run short jobs, some people run really long jobs, some people really know what they're doing and have been experienced for many years. Other grad students are new and sometimes do peculiar things. And since the system is shared and open, a user can affect the system, bring things down. I just very quickly looked at Cedar nodes yesterday, and you can see the kind of errors: disk errors, bad omnipath, some GPU reporting errors. And overall, I think on Cedar, we seem to have about sort of 4% of the nodes are down at any one time, maybe 3%, somewhere in there. But that gives you some idea that nodes are continually failing and having problems. Yeah, we replace the nodes. There's a vendor process, but the lesson out of all this is that users need to be prepared. Jobs will fail every now and again, and it's really good if you can use the best programming practices. And at that, it's over to Alex, who will talk a little bit about these programming practices.
Okay, let me share my slides. Just a second. Can you see my slides?
Yeah, there it is. Yeah, okay. Just came out.
Yes, excellent. So I'm going to just talk about some of these points in more detail. As Patrick mentioned, Cedar is a large and very complex system, so lots of components and latest hardware and bleeding-edge experimental software. So software has bugs, hardware might have problems, and because there are just so many components, it's guaranteed that some things will fail once in a while. We also have several shared file systems and a very broad mix of users and use cases, so that makes it really, really complex at the cost of efficiency and simplicity. So just to mention that we have 1,600 nodes on Cedar, 66,000 cores, almost 600 GPUs, and around 60 Sloan partitions to accommodate various types of jobs, so long jobs, intermediate jobs, short jobs, CPU versus GPU jobs, large memory, interactive, different CPU architectures, and so on. So it makes it really complex. So our goals are to provide as much uptime as possible, and if there are problems, and there are problems occasionally, then to work around these problems, fix them as soon as possible, and also provide you with the up-to-date information as quickly as possible. So we also, one of our goals is to maximize resource usage, so we try to make it efficient. CPUs, GPUs, memory, we all want to make sure that it's all used efficiently, and we also want to minimize the turnaround for your time, so the waiting time for your jobs in the queue. We are really concerned about that as well. So problems do occur, and one of the goals of these presentations is to show you what to do if there are problems, and in some cases how we can actually work around these problems. And also I want to show you some workflows that will lead to problems on the cluster. So some things you should not be doing definitely, and some things you should be doing. So just a walk through the best practices on the cluster. So in the next few slides, I'm going to walk through different types of failures, hardware failures. The first one is a node failure. So basically, a node needs rebooting or some other work. Perhaps it's stuck in a strange state, and all it needs is a reboot. Perhaps there is a hardware failure, a logic board failure, or a drive failure, and then those components have to be replaced. So out of 1,600 nodes on Cedar, probably on average at any given time, around 30 nodes have a hardware problem at any given time. And so these have to be fixed with the vendor. And so we're working with the vendor to get these continuously replaced all the time. And unfortunately, it's kind of slow. It's a difficult process to do it. So as Patrick mentioned, we are working with the vendor to simplify this process. So nodes can be marked offline in case of problems automatically by Slurm. They can also be offline. They can also be taken offline manually by us. So just a few examples of how Slurm decides that a node should be taken offline is, for example, when you're running a job on a node and that job has to be terminated at some point. So Slurm will try to kill all processes associated with the job on the node, and sometimes it will fail. So it will mark that node as temporarily unavailable. And then it's up to us to look at it manually and decide what to do, perhaps a reboot or hardware problem, etc. So sometimes a node will report unusually low memory. Sometimes it will report to Slurm an incorrect number of CPUs or GPUs. Sometimes it will not be communicating at all. So in all these cases, it's marked automatically offline by Slurm. So we'll also run some checks, and also users, well, you tell us about problems, and we'll notice some problems ourselves. So in that case, we'll look at those nodes as well. So one of the problems that I come across, well, fairly frequently is a GPU would start in a strange state. So for visualization, if you're trying to do OpenGL rendering on the GPU with hardware acceleration, you will get an error message about EGL rendering context not being available, whereas it is installed and should be available. So in this case, the only solution I know is to reboot a node, and we do it once in a while. Another problem that we see occasionally is oversubscription of nodes. So for example, several people can be using the same GPU at the same time, and obviously that should not be happening. Too many threads running on a node, and I'll talk about it in a few minutes. Another type of problem is a file system problem. We have 3 large parallel file systems: home, project, and scratch. And these are lost file systems that are served, so they have a large array of disks, hard drives, and SSDs. And these are being served by object storage service. So object storage service, unfortunately, can get overloaded sometimes with lots of small requests. So if there are lots of jobs doing I/O, high I/O, and especially lots of small random requests, this service, unfortunately, can fail. So we actually had a problem, exactly this problem 3 days ago, when a user was submitted about 100 jobs to doing a lot of I/O on project. And unfortunately, that led to problems. So one of the service was overwhelmed. It was launching too many threads, trying to process all this data, and it just went offline. So we had to reboot the server. But the end result is that project was not available to all users for about 3 hours. So unfortunately, things like that happen, and we have to solve these problems. So on all 3 file systems, the way Lustre works is these object storage servers are grouped into pairs of 2. And if one server in a pair goes down, then the other one is supposed to take over. So it sounds good, but that will come at the cost of speed. So because we have less hardware serving I/O requests, your jobs will run slower, and you will certainly notice that. So if 2 servers in a pair go down, then the entire file system is down. So in all cases, we have to reboot the service, and sometimes it takes time, and sometimes project might not be available. So the third large group of failures is a scheduler failure. So by using Slurm, an open source job scheduler and task manager, and Slurm, so we have, at any given time, we have thousands of jobs running on Cedar and thousands of jobs waiting in the queue. And Slurm is responsible for finding resources for the jobs. So when you submit a job, you're asking for some memory, some number of CPUs, perhaps GPUs, runtime, etc. And Slurm has to feed all those jobs onto the cluster. So there's a large optimization task with thousands of jobs waiting in the queue. And then it has to terminate these jobs to free resources. And problems happened. So Slurm, unfortunately, once in a while, it can get overwhelmed with too many requests. So for example, if you submit 10,000 jobs and using a job submission script, and then you decide to cancel in a few minutes these jobs, then this will certainly put a lot of stress on Slurm. So don't do that. And I'll come back to the best workflows for Slurm in a few minutes. And then Slurm has bugs as well. So unfortunately, it's experimental software. These things happen, and sometimes it can just be not responsive. So, and a couple of other problems that I want to mention is, one is lack of software synchronization between nodes. So these has to be dealt with manually, and also networking problems. So could be networking problems on the cluster, could be not networking problems completely outside of our control, somewhere on a campus network. And again, let us know about all these problems, and we'll try to resolve them. So how do these problems manifest themselves? Well, one of the most common complaints is a very slow job, so sluggish job. Job is not progressing, not outputting files as quickly as you expect it to do. And there's no single reason why these might be happening. There's actually lots and lots of different reasons. So it could be a file system problem, could be a node oversubscription, low memory, could be just saturated network. Perhaps your code is supposed to use a lot of, be sending a lot of MPI messages between different nodes, and somebody else is doing the same, or maybe hundreds of people are doing the same at the time, and it just happens that network is saturated. So if your code relies on lots of communication, it will be slow. So there are lots of potential bottlenecks. Jobs not starting, taking unusually long to start. So could be a hardware problem, but also there could be valid reasons why your job will not be starting. So if basically a high priority job can fit onto the cluster before your job starting time, then it is very possible that your job's estimated start time will get pushed into the future. And that's completely normal behavior. But if you suspect that something is wrong, let us know, and we'll look at that. So sometimes Slurm is just not responding. It's overwhelmed. So you type an SQ command or an SBatch trying to submit a job, and there is just no feedback at all. So unfortunately, once in a while that happens as well. So could be a bug. So last year we had this large problem with a bug in Slurm where you would submit a job, and very often it will start running, and it will get, when you type SQ, it will show you that it's in a prologue running state, but there is no output. So the job will not be progressing for many minutes or many tens of minutes, and Slurm is thinking that it's running, but there's no output. And unfortunately, it was a bug, so hopefully it's fixed now, but things like that happen once in a while. So sometimes you type a command, and the shell is not responding. So you type, for example, ls to list all files in the current directory, and it could also be slow depending on the file system. So if, let's say, project is running and Scratch is working, you will see this project when you are cd into a directory on project. Output files are missing from your working directory. You see an error message, module not found. So inside the running job, and that usually means that there's just lack of software synchronization between the login and the compute node. And sometimes you just cannot log into to the cluster. Perhaps your IP is blacklisted. Perhaps there's some networking problem. So in all these cases, let us know what exactly you're experiencing. But before you send us an email or submit a ticket, make sure that you take a look at the recent status messages for the system. So there are two things you can check this information. One of them is message of the day. When you log into a system, it will print out about 20 or 30 lines of recent updates. And if a system is down, if a file system is down, if there are some other problems, we usually try to include that into the message of the day. Also, probably if you logged into Cedar in the past few weeks, you saw the message about the upcoming today's outage maintenance. So all these things should appear in the login output when you just log into SSH to a cluster. So sometimes if you put some commands into your login script .bashrc or .bash profile file, then those commands output a lot of terminal lines, then the message of the day might actually scroll past the end of the terminal, and you will not see it. So in this case, make sure either you scroll manually to see the message of the day whenever you log into the system, or just not have any commands in your startup files that output a lot of text information into the terminal. So the message of the day, it's actually, there's a system message of the day for everybody, and also things like notifications specifically for you. So for example, Scratch purge notifications. If you have files in Scratch that are older than, let's say, 6 weeks, and these files are scheduled for deletion, we're going to put notices specifically for you into the message that you should see when you log into the system. The second place where you should check for problems, if you suspect there is a hardware failure, is the status website, so status.computecanada.ca. We always list any recent problems, perhaps with some delay, maybe 20 minutes, but check that website as well before you submit a ticket that you think has something to do with hardware failure. And then if you don't see any updates, if you want to report a new problem, please do. So send an email to support@computecanada.ca, and this email will automatically go into our ticketing system. So try to provide as much information as possible. And if you think that we need to solve this problem, we need to look at your files, for example, the job submission scripts or the output files or the error files, please make sure that you give us you give consent for analysts to look at your files, because usually we don't have that permission. So the way to do that is you can log in with your Compute Canada credentials to the Compute Canada database, so ccdb.computecanada.ca, and you will select My Account Agreements and then check the box to give us consent, and you can revoke it at any time after the problem is solved. So what can you do when there's a problem? Well, if it's a specific file system problem, then you can actually try to work from a different file system. So today project, well, not today cluster is down, but when Cedar comes back, hopefully tomorrow, then project is not going to be available, but you can still work from other file systems. Of course, there are limitations, so we do not recommend that you run anything large in home, because home is just not well-performing system, has a small quota. But in some cases, it is possible to switch temporarily to a different file system. Also, if your job is not starting, it has spent a lot of time in the queue, don't delete and resubmit it, because this will not solve the problem. Because in order to find out why a job is not starting, we really need to look at the job while it's sitting in the queue, and then we'll be able to find out why it's not starting. And also, you may lose priority as well. So the priority for a waiting job is growing very slightly with the waiting time. And then if you submit a job that's been waiting in the queue for a few days, then your priority for the job will simply go down as well. So after a system comes back, expect some backlog of jobs. So don't submit lots of thousands of jobs. Don't submit anything intensive. Please allow, I don't know, a few days for the backlog to clear up after the system comes back online. So next, I want to go through some of the problems some of the workflows that will create problems on the cluster. So as you probably know, you should not be running anything intensive, especially CPU intensive, on the head node. And the reason for that is because there are two login nodes, the head nodes, and these head nodes are meant for as a basic interface to the cluster. So people log in, they use login nodes to submit jobs, to check currently running jobs, to look at the results of the simulation runs. So if you submit a lot of CPU intensive calculations if you do a lot of CPU intensive calculations on the head node, it'll just make life miserable for everybody. And the head node is going to be very slow. So please don't do that. Submit anything CPU intensive, any production jobs through the regular sbatch and salloc commands. Then submitting a large number of jobs will make the scheduler unstable. Well, could make the scheduler unstable, or could just overwhelm it, so everybody else on the system will not be able to submit jobs. And the same goes for issuing too many requests to the scheduler. So please never do things like type commands watch SQ. So watch is supposed to run a command once in a while, let's say every minute. But if you run SQ often, then that will actually put a lot of stress on the scheduler. So please don't do that. Also, using a script to submit thousands of jobs and then canceling them, what I mentioned before. So that will also put a lot of load on the scheduler. Also, complex and unrealistic job dependencies. So job dependencies are good. You should be using them. But sometimes if you have too many of them, that they can make Slurm unstable, so you should be aware of it. So testing is super, super important. anytime when you submit anything large, whether it's a long job, a large scale calculation, a large parallel job, make sure that you test everything. You test scaling. So for example, for a parallel code, make sure that you test scaling and you run it first for a smaller problem size on a few processes and see how it scales as you increase the number of processes. Because in parallel codes, there are always bottlenecks. And sometimes you will see that a parallel code will not perform faster on, let's say, 64 cores than on 32 cores. There are always bottlenecks on these plateaus, performance plateaus, so be aware of this. The same for any type of code, whether serial or parallel for large calculation. Make sure you time it, make sure you understand how it scales for the problem size, how much memory you're using, how much runtime, etc. And make sure that these make sense when you apply, when you actually submit a very large problem on the cluster. Next, for the file system. So as I mentioned, lots of file systems, they are not really optimized for high IOs, for numerous random IOs. They're really optimized for large sequential reads and writes. So if you do any small reads and writes, for example, you have many writing from your simulation into lots of small files. If you frequently read and write in chunks smaller than, let's say, 1 megabyte, or reading small chunks, small fragments from a large file, and do it frequently, all of this will lead to a lot of stress on the loss of file system because it was not designed for high random I/O. It was designed for large sequential I/O. So the same goes for storing a large number of files. So on your laptop, if you have a directory with, let's say, 100,000 files, and you cd into the directory and type ls, then your laptop might pause for a second or two, and then it will just print all the names of all those files. Not on Lustre. So if you try to do it on Lustre, it will actually hang the entire file system, because Lustre is not designed for storing a large number of files. It's designed for storing a small number of large files. So what you can do, if possible, organize your code's output. So modify your simulation code in such a way that it outputs a small number of large files as opposed to a large number of small files. Also use tar, so the archival command, there are other archival commands as well, so to archive and compress your numerous files into few large archives. Another problem that we see quite often, especially with beginner users, is they don't know how the code was parallelized, and they don't understand how the job should be submitted to the cluster. So sometimes they're running a black box pipeline, not aware that the code was written not for a cluster, but for a large memory standalone server. And that happens quite a lot in bioinformatics, where you run a code and it tries to launch as many threads as possible to fill the entire system. And unfortunately, this is bad for the cluster, because a cluster is a shared resource. So any node is supposed to be shared among many users at any given time, right? So if you're not sure, please talk to us, and we'll be happy to help you. So another problem that analysts asked me to mention is the move command. So this is a misunderstanding about the way the coders work on different file systems on Cedar. So when you create a new file in Home and Scratch, that file will have a file ID, a user ID that is your username, and then it will have a group ID that is also the same as your username. When you create a new file in Project, its group ID will be the group ID of the research group to which you belong. So this is done specifically so that when you run quota, that quota checks for all files with a specific research group ID, and then if the total usage is more than, let's say, 1 terabyte or 5 terabytes or 10 terabytes, then you're no longer able to, any group member no longer able to write into Project. So what happens when you try to move files from either Home or Scratch into Project is that the move command will preserve the group ID. And so that group ID in Home and Scratch is your username. And the quota for your username group ID on Project is almost nothing, something like 2 kilobytes. So very soon, when you start moving those files into Project, you will get an over-quota error. And the reason is because these files, when they're moved to Project, they will have the wrong group ID from a different file system. So what you need to do is, instead of using move, please use copy following by remove in the original file system. And that will, so the copy will actually modify the group ID so that the quota is computed correctly. Other best practices, implement, use checkpointing. So checkpointing refers to a periodic dump of your simulation at intermediate steps, so that if there's a hardware failure, if your job crashes, if a node crashes, then you can actually restart your simulation from an intermediate data dump. So lots of codes have checkpointing. I mean, this is really good practice. If you have any large simulation, then the simulation code has to have a checkpointing capability. If it does not, let us know, talk to us. But if you have checkpointing in the code, please use it as often as it makes sense. So perhaps once an hour, once every 30 minutes, and so on. So next, break your job into pieces, and that goes for both simulations that use lots of processes but don't have to. So for example, sometimes people write parallel codes that can actually be trivialized, that could be broken into a number of serial calculations, so serial farming. Try to submit multiple serial jobs as opposed to submitting one large parallel job, because it is much easier to schedule a serial job. The same goes to workflows, especially again bioinformatics. So in bioinformatics, there are a number of workflows that combine a lot of steps into a single job on the cluster. And some of these steps are serial, some of these steps are parallel. And if a serial step takes a lot of time, then all other cores that were allocated to your job will be sitting idle. And it's just not efficient usage of a supercomputer. If you're not sure, again, how to do this, let us know and we'll help you. So read all documentation that's related to scheduling, submitting jobs, using modules, other topics. So our documentation website is the wiki, docs.computecanada.ca. And so everything I'm mentioning today is described there. So make sure that if your code is parallel, you know how it was parallelized, because quite often, especially when I teach workshops to beginners, somebody comes up to me and says that the code is performing very slowly. They don't know why it's happening. And we take a look at this job submission script, and it turns out that they have not adapted the job submission script to reflect the parallel nature of the code, how the code was parallelized. So whether it's a shared memory code, so using threads, or a distributed memory code. So this information, knowing this information, is crucial to write the correct job submission script. So make sure you know this. If not, again, let us know, and we'll be happy to help you write the right job submission script. So testing, I mentioned that again. So there are a couple of commands that are really useful to find out how much memory your code is using. So for any completed job, you can run the SACT command or SF command followed by the job ID and perhaps some other flags. And that will tell you how much memory your job is using. So it is very important to specify the right amount of memory and the right runtime when you submit a job, simply because if you specify too little, your job will be killed when it reaches those limits, either runtime, maximum runtime, or the amount of memory. It will be killed. If you specify too much, then your job will just end up spending a lot of time waiting in the queue, right? Because it's a larger allocation that you're asking for, and it's just more difficult to fit it onto the cluster. So make sure you know those numbers, and use SACT and CEF commands. Give yourself a little bit of a cushion, maybe 10, 20%, and then you should be good. So other best practices, if you're still running a job that does a lot of I/O, small random I/O, this is really bad. But if you just have a black box code that you don't understand, you don't know how to modify it. So what you can do is to remedy the problem, you can, instead of writing to a parallel file system like Scratch, for example, you can actually write to a on-node SSD. So when you submit it, so it's a local SSD on the physical node that is running your job. When your job starts, Slurm generates a directory that is /local Scratch, so that's a node SSD. / your username .job ID .0. So it's a temporary directory that's going to be there for the entire duration of your job. And you can actually write files directly into this directory. So if you're using these environment variables, you will always know where the directory is, because those variables, so the Slurm job ID variable is always initialized when your job has started. So The only caveat here is that that directory will be deleted when your job terminates. So make sure that in the job submission script, before you terminate your job, you move the output files from that directory somewhere to a more permanent location, for example, Scratch or Project, etc. You can also use a RAM disk. So a RAM disk is a / TMP file system, and it's just a RAM disk. So it's very fast, much faster than even SSD. So the problem here is, well, there are two problems. So first of all, when you submit a job, you need to allocate sufficient amount of memory to account for any RAM disk usage you're going to do. And then also that directory, so that those files are going to be deleted when your job terminates. So make sure that at the end of your job submission script, you actually move the output files from / TMP somewhere else to a more permanent location. So,
Alex, I just noticed there's a question on the chat there about files.
Mm-hmm.
Yeah, is it better to use Scratch when you've got a high number of writes to a file rather than project?
Yeah, well, it is better to use Scratch, but Scratch also has limitations because Scratch is more high performance, so it'll probably perform better in that regard than project. It will, but there are limitations. So if you have a lot of small files, then Scratch might also run into an overloading problem, right? So in that case, if that happens, if you suspect that might happen, try to use well, RAM disk or a local SSD on the node.
Thanks, Scott.
Okay. So you can also try to port your workflows to another Compute Canada general purpose cluster. So we'll have next month, we'll have Niagara, and of course we'll sorry, not Niagara, Beluga, hopefully, and then we'll also have Graham. And if Cedar is down, then you can actually try to run codes on Graham, right? So if you require your code requires a lot of input data, then you can use Globus to actually port those data sets to transfer them to Graham, right? So have a backup in case a cluster goes down or there's a hardware problem to be able to run the codes elsewhere. So the same goes for local resources. So in some cases, we actually have local clusters, so Drax in Manitoba, Orcinus at UBC, etc. And these clusters are available for you. And in case you have problems on Cedar and Graham, you can actually use those clusters as well. So if you receive the Scratch purge warning, your files were in Scratch for a long time, do not wait until the last minute to move them, especially if you have gigabytes and terabytes of data, because moving data takes time, and you should start early. Other best practices, so we already mentioned that a couple of our file systems are backed up, so Project and Home are backed up, but Scratch is not. And also Scratch has a purge policy, so files will not stay there forever. So make sure you account for this in your data management practices. If a file, so in a system that is backed up, if you change the path or the name of a file with lots of files, then the backup utility will not know that these are the same files. It will just try to back up them again. And this might actually put a lot of unnecessary load on the backup service simply because, well, these files were backed up previously and you just changed the name or the path. So try to avoid doing that on very large data sets. So do not run things in Home in general, because Home is a not well-performing file system. It has a small quota, and it's also backed up, so that puts a lot of stress on all these components. After your job finishes, make sure you clean up. You tar large number of files. You move large files elsewhere, archive them, etc. Oh, that is my last slide. Yeah. So and I think that's all I wanted to say. I didn't realize it was my last slide.
Thanks, Alex. Yeah, that's great. I think you covered pretty much everything there. Any other questions?
Yeah, I wasn't paying attention to the chat window. If there was something else.
No, I think other questions were answered as we went along.
Okay.
By other analysts. So I think that worked fine. Yeah, that's great. I just make the note that it's really easy when running, especially off-the-shelf applications, just to run them for as long as they need to go and give a wild overestimate on how much memory and runtime CPUs are needed, just because you want it to run. But it's certainly well worthwhile to try to get those things as accurate as possible, just as Alex has talked about, and to yeah, run the easy ones for a little bit, but then put some effort into fixing up the job scripts and doing all these things that Alex has mentioned. And I think we'd all appreciate it if PIs and team leads could suggest to their grad students and such that it's worthwhile making sure your codes run. I think overall it really is. Losing especially a long, big job, you know, just before it ends is such a pain, and you have to go back and figure out and redo it. So these best practices are really worthwhile. And I'll just finish by noting that Lance indeed was working away on the Cedar stuff and sends his apologies. But I think the key here was Alex's suggestions. So I think that's about it. Do we have any other questions? Notes from anybody?
So these slides were posted online. There's a link that was provided at the beginning of the chat, at the beginning of the session. And also we're going to post it, we're going to add the slides to, and this recording as well, to the training materials page. So just Google training materials WestGrid, and it'll go most likely into the getting started section.
Cool.
We can share the link with everyone who RSVP'd to today's session as well.
Thank you.
Thanks, Aaron. Yeah. Okay. Otherwise, that's great. And thanks for everybody for attending, and thanks, Alex, for presenting that. Right.
Thanks, everyone.
Bye, everyone.